Hey everyone, and welcome back to my channel. Have you ever felt like your money just disappeared? 1 minute it's in your wallet, and the next, poof, gone. Tracking expenses can feel like a chore, but what if I told you we could build a smart personal expense tracker that helps you see where your money goes? Imagine you are trying to save up for the dream gadget or a fantastic vacation. You are making good money, but at the end of the month, your savings account looks stagnant. You need a way to visualize your spending and understand your habits. That's exactly what we are going to build today using Python's powerful Flask framework. In this video, the first part of our series, we'll deep dive into the code behind the core features of this amazing app. We'll cover setting up our Flask application, designing our database with SQLAlchemy, implementing secure user authentication, adding, editing, and deleting expenses and categories. And stay tuned because in the next episode, we will supercharge this app by replacing our basic suggestions with a truly intelligent AI feature. Ready to become a financial wizard? Let's jump into the code. Every great application starts with a solid foundation, and for our expense tracker, that's our database structure. We define this in models.py. First up, we import SQLAlchemy. This is our object relational mapper or ORM. It lets us interact with our database using Python's object instead of raw SQL queries. We also bring in user mixin from Flask login, which provides default implementation for user properties needed by Flask login. Then we initialize db equals to SQLAlchemy. Creating an instance for our database. This db object will be used throughout our application to interact with the database. Think of this file as a blueprint for how our data will be stored. Our first model is user. It inherits from db.model, making it a database table, and user mixin. This creates an ID column, an integer, and set it as a primary key. Every user will have a unique ID. The username column will store string up to 100 characters. Unique equals to true ensures no two users can have same username. And nullable equals to false means it can't be empty. This stores the user's hash password, 200 characters, because hashes are typically quite long. Now let's create our core model, expenses. This is where each individual spending record lives. Amount is a float for decimal values. title, amount, and date. These fields are self-explanatory. This is a foreign key. It links each expenses to a specific user ID. This ensures only the user who added the expense can see or modify it. Another foreign key, linking the expense to a specific category. This helps us organize and analyze spending by type. Finally, the category model. This is where we define types of expenses like food, transport, or entertainment. I'll just copy the category model from earlier and paste it here. You can also do the same if you'd like. The full project link is in the description. ID, name, description are pretty straightforward, similar to the user model. This is where the magic of relationship happens. It tells SQLAlchemy that a category can have multiple expenses. Backref equal to category creates a category attribute on the expense object, allowing it to easily access the category details from an expense. Lazy equals to true means the related expenses will be loaded when accessed. So, models.py sets up our database tables and how they relate to each other. It is the backbone of our data. Alright, models done. Time for a quick break. Go grab a coffee, hydrate, or just chill for a minute. We'll be back fresh and ready for the next step. Now that we have our data structures defined, let's look at app.py, which is the main application file. This is where all the logic, routing, and interactions happen. Let's import the models. We are importing a lot here. Flask is our web framework. Render_template template helps us display HTML files. Render and URL_for are for navigating between pages. Request lets us access data from forms. Flash is for sending one-time messages to the user, like the registration successful message or some error messages. For Flask login, we get login manager for handling user session, login_user, logout_user, login required, which is a decorator to protect routes, and current user to access the logged in users info. This provides two methods: generate password hash and check password hash for secure password handling. Datetime is for working with dates, though in this specific code, dates are stored as string for simplicity. This creates our Flask application instance. A secret key is crucial for session security. Important thing is to remember in real application, this should be a strong randomly generated key stored securely, not hard-coded. This tells SQLAlchemy where our database file is. Here it is simple SQLite database named database.tb in the same directory. This disables a feature that consumes extra memory as we don't need it for this app. This connects our SQLAlchemy database instance to our Flask application. Let's import the models as well, which we declared in models.py, like user, expenses, and categories. Here we initialize Flask login and link it to our Flask app. If a user tries to access a protected page without being logged in, Flask login will redirect them to the login route. This decorator tells Flask login how to load a user from their ID. When a user logs in, their ID is stored in the session, and this function retrieves the user object based on the ID. Phew! That's a lot of setup, but it is essential for a robust application. Now let's look at the actual web routes. This is our very first route. It is the home page. Here I'm just going to return a h1 message. Hello world. This standard Python construct ensures the code inside only runs when the script is executed directly, not imported as modules. This creates an application context which is necessary for interacting with Flask extensions like SQLAlchemy outside of a request. db.createAll is super important. It creates all database tables we defined in models.py if they don't already exist. app.run, this starts the Flask development server. Debug equals to true gives us helpful error messages during development. Alright, now let's execute the application and let's fix if there are any bugs. So we have a small bug here, which is the SQLAlchemy _database URL. It should be URI, not URL. So let me correct this and rerun the application. Finally, we can see the output, hello world. So this is the root URL. When you visit this root URL, we will be redirected to the root route. So in the root route, I have just given a hello world message, which is why we are seeing this. Register route handles user sign up. This route responds to both GET request to display the registration form and POST request when the form is submitted. If the form is submitted, we get the username from the form data. We hash the password using generate password hash. Never store plain text passwords. Hashing makes them unreadable and secure. We check if a user with that username already exists in our database. send a message to the user saying user already exists. Otherwise, this code will create a new user object, add it to the database session, and save it permanently. We then flash a success message and redirect to the login page. If it is a GET request, we simply disable the register.html template. Let's execute the application one more time, and we'll try to navigate to the register URL. Again, this is the home page, that is the root route. Now let's navigate to the register route. Alright, we have a bug here. Let's fix this. So the issue here is I have not created the register.html template yet. Let me create this and we'll rerun the application. Finally, here is the register template. Since we don't have any content on this template, we are seeing blank page. Let me add a message in register.html. Alright, so this is the register form. The login route is similar to the register, but for logging in. If it is a post request, we fetch the user by username. We check if the user exists and if the provided password matches the stored hash password using check password hash. If successful, login_user logs the user in, setting up the session and we redirect them to the dashboard. Otherwise, an invalid flash message is shown. For GET request, it renders login.html. The dashboard is the heart of our application. Login_required. Again, only logged in users can see their dashboard. In this line of code, we are querying the expense model and filtering it to show only expense belonging to current user. This block calculates the total amount spent for each category. It iterates through all the user's expenses, get the category name, and sums up the amount. Basic suggestions logic. This is our current simple AI part. We only proceed if there are expenses. This code finds the category with the highest total spending. If the highest spending category exceeds $3,000 or rupees, we add a warning suggestion, otherwise a positive message. You can easily change this threshold or add more complex rule. But get ready, because in the next episode, we are going to completely replace this with a proper AI integration. Finally, this code passes all the necessary data like username, expenses, category name, totals, and suggestions to the dashboard.html template for display. The add route allows user to add new expenses. If it is a post request, we grab the title, amount, date, and category IDs from the form. We are converting amount to float for decimal values. We create a new expense object, associating it with current user ID and the chosen category ID. This code, which is session.add and session.commit, saves the new expense to the database. A success message is flashed. The user is redirected to the dashboard. For get request, it renders add underscore expense file, and let me pass the categories list. Editing expenses is handled by /edit/then id, where int id bar means the URL will have an integer. Like this, Flask will pass 5 as the id argument to the function. We try to get the expense by its id. If it doesn't exist, Flask automatically returns a 404 error. Security check. We ensure that the logged in user is actually the owner of the expense they are trying to edit. If not, we flash an error and redirect. If it is a post request, we update the expense object's attribute with the new form data, and session.commit saves the changes. For get, we render edit_expense.html, pre-filling the form with the expenses current data. Deleting an expense is straightforward. /delete and then the ID. Similar to edit, we fetch the expense and perform an authorization check. Session.delete marks the expense for deletion. Session.commit permanently removes it from the database. A success message is flashed and we go back to the dashboard. We also have a full CRUD functionalities for categories. This logic is similar to the expense management. So I'll just copy the routes for categories from the project which is uploaded to GitHub, and I'll just paste it here. That's the Python backend. It handles all the data, security and logic. But what about what the user actually sees? That's where our HTML templates come in. Our Flask app uses Jinja2 Templates to generate dynamic HTML pages. We'll use Bootstrap for a clean, responsive design. Let me just copy and paste all the HTML templates for this project and we'll go through each important Jinja2 code. Base.html is our main layout. It includes HTML structure, a title, and a link to Bootstrap 5 CSS for styling. This Jinja2 block is crucial for displaying those flash messages we saw in app.py. It iterates through each message and displays them as Bootstrap alerts. Block content and end block. This is a placeholder. Other templates will extend base.html and fill in these content blocks with their specific HTML. Register.html and login.html are very similar. They inherit from our base layout. They define the content for the placeholder, the block content. They contain a simple form with post method to send data to the Flask route, and I'm using Bootstrap classes for designing the elements. URL_for. This Jinja2 function dynamically generates the URL for login route, making our links to robust HTML. Let's execute the application now and see the output after designing the login.html. Oops, I forgot to remove the header tag from the root URL. Let me quickly remove it. So this is the login form, right? We are using Bootstrap 5 for designing, and this is the register form. Looks clean and nice, right? Dashboard.html is the most feature-rich template. Here we have a welcome message, displays the logged in user's name, navigation button for adding expenses, managing categories and logging out. This conditional block only displays the AI suggestions if there are any. Now we are going to display a bar chart in our dashboard to highlight the expenses and each category. This is where our beautiful chart will be drawn. We include the chart.js library to create interactive charts. This JavaScript block initializes the chart. This is where Jinja2 dynamically inserts Python categories and totals lists directly into the JavaScript, converting them to JSON format. Add underscore expenses and edit underscore expenses cleverly share the same structure. This Jinja2 conditional renders edit expenses if an expense object is passed, meaning we are editing, and add expenses otherwise. For input fields, this pre-fills the value if expense exists, otherwise it's empty. The select element for categories loop through categories and uses this code to pre-select the correct category when editing. Alright, let's execute the application now and see the output. Oh my god, I'm learning, guys. Let me create the logout route. Alright, so we have completed the development of this app. Now let me run this application and see the final output. Also, let's fix if there are any bugs. Method not allowed error usually comes when we forget to mention the action attribute in a form. In this case, I forgot to mention the action attribute in the form in login page. I'm such a stupid person. Yeah, let me fix this. Finally, this is the output. This is the dashboard. This is how it looks. We have the expense, add expense button, manage category button, and there is a chart. We have not created any expense category yet, so let me create one. We have another bug. Let me correct the spelling. Alright, done. So if I refresh this page now, and that's it. So this is the dashboard. Here is the AI suggestions and the JavaScript chart we created. If you see the chart, the total amount, the category name, and the AI suggestions, these are not coming correctly. So there is a lot of improvement we can do. Can you fix these issues? Download the project from the link below and try to resolve this. I will fix this issue and re-upload the project in the GitHub, and I'll share the solution in the next episode. And there you have it. The core of a complete functional expense tracker built with Flask SQLAlchemy and Flask login. We covered everything from database design to secure authentication and dynamic data display with charts. This project is a fantastic starting point for anyone looking to build web application with Python. But we are not done yet. In the next episode, we'll take this app to the next level by implementing a more sophisticated AI-powered suggestion system that will give you even smarter insight into your spending habits. You won't want to miss it. If you found this video helpful, please give it a big thumbs up, subscribe for more coding tutorials, and hit that notification bell so you don't miss part 2. Thank you for watching. Happy coding. See you in the next one.